First, let's start with who we are. A quick set of introductions. I'm Sri, obviously I run Global SRE for a line of business within Standard Chartered. I've been in the industry now 25 years, largely in financial services. Worked across the globe. Singapore is home. I've been here for 20 years. My hobbies are world music, cricket, traveling, photography, flying kites, and chasing UNESCO World Heritage Sites. Ian?
Hi everyone, my name's Ian Hamilton. I live and work in Singapore, so sadly no travel for me this week, still feeding the cats at home. I've had around 20 years in build and maintain roles in financial services. In my current role at Standard Chartered, I help people get better at measuring reliability and elevating reliability, and SRE is a key part of that approach. If there's any bits that you want to talk about in more detail, you can grab us afterwards. And I'm now going to hand you back to Sri for a little bit about the people that pay the bills.
Thank you. How many of you from financial services here? Raise of hands quickly. Okay, good. So Standard Chartered, we are part of Standard Chartered. We are a 160-plus-year-old bank. We operate across 59 markets. I work alongside 80,000-plus colleagues across 131 countries. So obviously, we take pride in the diversity that we bring in. We are one of the largest firms in the top 100 listed in the London Stock Exchange. We have been recognized as world's best employer in 2022 as part of Forbes. Traditionally, Standard Chartered has been a trade finance bank, but over decades, we do offer all banking services for corporate and retail customers. Because of the number of years and the geographies we have been in, we also have a digital license in Hong Kong and Singapore. Those banks are known as Mox and Trust. Those in Singapore might have heard about Trust. We also have a ventures business, which is got a portfolio of 22 companies and 30 plus ventures. Okay, so where do we sit in the overall Standard Chartered organization? So we're part of corporate, commercial, institutional banking. In common language parlance, people may know it as wholesale banking. So the two business driving units are transaction banking and the financial markets. Financial market means investment banking. Transaction banking is two lines of business, which is the cash business and the trade business. So cash essentially means payments, lending, collection, liquidity. That's the line of business. And trade is invoice financing, supplier finance. Okay. Now, transaction banking is becoming extremely digital, so it's a very fastly evolving space. Because of the digitization, obviously, client experience is paramount. And in the overall scheme of things, we're part of production engineering, and we've got 3 flavors of SRE that support that line of business. One, which is closely associated with the individual verticals within the line of business. So you have got digital channels, transaction banking, client coverage, and financial markets. We've got SREs aligned to those verticals. And then we've got embedded SREs who actually work with the feature engineers to build non-functional requirements into the platform. And then we have a core engineering team that sits across helping build capability. Okay. Why are we here? Okay, we are 3 years into a big transformation that we are doing within the bank. It impacts 500 plus of our engineering colleagues who support more than 100 plus applications. We want to share our story. It's a story where we will share things that we did right, things where we failed. We did fail fast and course correct. We don't know all the answers, but we think we have most of the answers. And we hope that what we present would be like a run book for other organizations who would want to embark on a transformation journey like ours. And at the end, we welcome feedback from all of you. Okay, so why was transformation necessary for us? Now, even pre-COVID, there was significant digitization that was happening. Once products are getting digitized, we were rolling products out fast across markets. And obviously, you need to have speed to market advantage. So we were changing the features and the architecture across the estate. Now, architecture, for our architecture is quite complex because we have old and new technology interweaving together. And because it's complex, when we start adding features, it becomes even more complex. But at meanwhile, customers are expecting platforms to be always on, and they also want to be always aware. Now, because of the speed to market, and because we are delivering capabilities so fast, at times we've seen that we do compromise, not intentionally, the end-to-end design, which then brings in reliability challenges and toil. Okay, those who are in Singapore might have seen these headlines. This was from Q1. There was a banking incident, and the regulator gives us enough incentive to push for more reliability, and we believe that regulators would want to gamify reliability statistics across banking financial services, similar to what they do for ISPs. Okay, this is an inspirational slide, both SREcon and Guinness. We first went to SREcon in Dublin in 2019. We were doing a lot of experiments then. Little did we realize that what we were doing was actually what SRE should be doing. Now, with that inspiration, we had an aspiration that we will come and present our story someday, and that day is today. With that, I will cover what we are going to share. I'm going to cover the tenets. We will talk about the transformation journey, which includes people, process, and tools, and we'll wrap up with some takeaways. And I'm going to hand it over to Ian to cover tenets, people, and process. Ian, over to you.
Thanks, Sri. So, quick disclaimer before we get started. I did write final version may be different, but I think final version will be different. We're still evolving. We're very much on a journey, as is SRE, and so we're continuing to make adjustments as we go. So, yeah, we have answers, but not all of them. One of the first things we did, well, firstly, I'd like to set some context around what our SREs do, so you get a feel for that. And then I'll talk about how shaping what SREs do helps structure our transformation. So one of the first things we did when we embarked on this journey was to define a North Star framework, SRE tenets and subtenets, because SRE is an incredibly powerful concept because it can be applied in so many different ways. But then this also suggests that SRE means different things to different people. Everyone's got their own view of SRE. Is it site reliability engineering, service reliability engineering, system reliability engineering? Everyone's got their own flavor. And so when you get down to implementation, it's important to provide a bit more clarity, low-level detail about what your flavor of SRE is going to do. And this helps avoid any disconnect with key stakeholders and also give people transparency on what role you're envisioning for SREs within your area. Because at the end of the day, they're going to make a career change to follow you, to be an SRE, and it's important that expectations are clear. SRE can also be misunderstood. You talk to people about SRE and they say, oh, I've been doing that for years, or you're just L1, L2 rebranded. Also, SRE is a popular job title to have, and sometimes maybe people change their job title to SRE without having that software engineering substance behind it. And we were very adamant that if we were going to overcome those digitization challenges that Sri described, that we needed software engineers in the role. And this framework that we created helps control that narrative around this new role that we were creating in the company. It didn't exist previously. There was no internal reference points. We couldn't go and observe in a different part of the bank what SREs do. So it was from scratch that this has been created. What this framework also helped us do is, once you get going into the transformation, you're a year in, perhaps you get a bit lost, disorientated, confused. This framework provides a reference point that you can refer back to just to validate the path that you're on. So it was an anchor for our transformation because it doesn't just show what we're going to ask SREs to do. By extension, then, it's also showing the non-functional capabilities that we expect our applications to have. So when we say in the reliability pillar, auto-deploy, auto-heal, yes, we want our SREs to do that, but we also expect our applications to have that capability. So when I say that this framework anchored our transformation. I really meant it. It's at the core of everything that we've done. Everything has lineage back to this tenet framework. So the role profiles and skills were determined by the activities that we described in the framework. From the role profiles and skills, then we could roll out a learning and development program. Progressive career paths then extended from the roles, and our SRE certification, which is an internal benchmark, again, had lineage back to the activities that we described. Our transformation program structure has a roadmap with the pillars in the roadmap have lineage back to the tenets. So when people look at our roadmap, they can see where in this framework we're looking to have an impact with our strategic initiatives. Our SRE ways of working, so the way our SREs structure their backlog, structure their book of work, has lineage back to these tenets and subtenets. And our governance, so when we assess system capability or we assess people productivity, where are people having an impact, we do it with lineage back to these tenets. So I think these tenets gave us the foundation from which we could confidently transform. Okay, so I've spoken a little bit about what SREs do and how this helps structure our transformation. I'm now going to talk about people, specifically learning and development. So when we thought about those digitization challenges that Sri was describing, it was clear that if we wanted to overcome those challenges, we needed to have a rethink, a recalibration of our organizational construct. The traditional L1, L2, L3 model wasn't going to allow us to elevate our service, elevate the reliability for these digital products. So if you think about L1, depending how it's implemented, is either strong functional people facing off to the business, answering their questions, or it's people doing first-time fixes from runbooks for known issues. Both of these activities can be automated away. Your functional queries can be automated via virtual assistants. And if you know what the issue is, you've got a runbook, you should be looking at auto-heal rather than having someone to do that manually. So we didn't need an L1 function. The L1, L2, L3 model also implies that your strongest engineers sit in L3. And that's a problem when you've got high expectations from your customer because they're two escalations removed from the first responder. And that time you lose, the turnaround time you lose, and also the loss of context as information's passed through those tiers doesn't allow you to respond effectively. So our L1 and L2 people, they were upskilled either into data engineers sitting in our production intelligence center, and these are people that unlock the potential in all that observability data that we aggregate, or they were upskilled into SREs, which is what we're talking about today. And most of the L3 people were also upskilled into SREs, which they were already strong, so it's more of a mindset shift of how we wanted them to manage reliability. Okay, so I'm now going to talk in a bit more detail about how did we bridge that skills gap. I appreciate some of these slides are a bit busy. It's because we want to give you implementation guidance of runbooks, so there is a lot of detail there, but I will explain them. Obviously, the deck will be available afterwards. So when we're bridging that capability gap, there was 3 key components to it. A, B, C. A, we want to develop a learning pathway that empowers people to bridge that gap to the SRE target skill set. B, certification. So we need to have a benchmark to make sure we're training people to the right level so they're going to be successful in the role. And C, progressive career pathways. We wanted to make sure we had the framework to retain our best talent. So I'm going to talk about each of these in a bit more detail now. So A, learning pathways, our education program. We wanted to build T-shaped or pie-shaped engineers. So to do that, we identified a set of essential disciplines which were mandatory for all the engineers. So the essential disciplines give you the breadth of the T, but we only ask people to learn them to maybe a foundation or intermediate level. And then to complement the breadth, people have the option of choosing specialist electives, which they go deep into, and that depth from the specialist that they choose based on their team, their tech stack, gives us the T or the pie-shaped profile. The specialist electives, because more depth is required, they learn to an advanced or expert level, and I'll talk about that in a bit more detail in a minute. So this T-shaped profile, the engineering profile, or pie-shaped if someone's particularly strong, form the basis of the SRE certification program. But we didn't just stop at technical skills. We wanted well-rounded people. So to complement the technical skills, we wanted to make sure everyone understood what the SRE concepts are. SRE is very powerful in the way it teaches you to manage reliability through SLIs, SLOs, error budgets, etc. We wanted to make sure people understood that. So all our engineers have sat the Google measuring reliability course on Coursera. We also wanted people to be able to innovate. So all the engineers going through the certification program have participated in a hackathon to demonstrate they can be nimble and agile. And all the engineers also have had to host a workshop or a peer coaching session to give back to the community to kind of amplify this L&D curriculum that we're rolling out, encouraging people to give back to others and help others maybe earlier on the journey than they are. So these 4 elements, the technical T-shaped profile, hackathon, Google course so you understand the concepts, and the workshops combined to create this SRE certification. And the reason we did this, and we're quite rigid around this, is we want to make sure that if people are choosing this career path, they're going to be successful in the role. We don't want people to think we want them to swim, because if they swim, our organisation is going to be successful. So we wanted to give everyone the best chance of swimming. And then the last piece of the puzzle is this progressive engineering pathway. So I think if you think about how progression is often managed in technology roles, you need to take on line management, people management to become more senior. Not all engineers want to do that. And if we were going to retain our best engineering talent, we needed to make sure that we had a way to offer people to have a bigger impact and take on more responsibility in the bank without necessarily being a people manager. And that's what we defined in the progressive engineering career pathways. And it goes right up to distinguished engineer, which is a very senior role in the bank, to make sure that we retain our best people. Okay, so a little bit more on those skill levels. So to support or empower self-learning, each of those essential disciplines that give people the breadth and the specialist electives that give people the depth are broken down into the underlying skills within those disciplines. So for example, one of the disciplines is programming. We don't want to be too prescriptive because everyone's got a different tech stack, a different environment that they work in. So we set the skill level at a discipline level. You must have an intermediate level programming competency. Then within the discipline, we define the skills that are available within the bank: Java, C#, Python. And each of those skills get broken down into those 4 skill levels. Within the skill levels, the proficiencies that we expect people to learn are defined. So they can look at the skills catalog at the skill and see, self-evaluate, where am I today? And then understand what they need to learn to get to the next level. And below the skill levels are the links to the training material, classroom-based training, online training, where they can go and get those skills. Okay. So that's our L&D. I'm now going to talk a bit about process and how this kind of unlock the potential of all those people that we're training. Because SRE is a lot more than just having the skills. Having the skills is kind of a little bit, so what? You're not an SRE yet. There's a way of working that SREs need to develop to be effective. Okay. Yeah, so we had a challenge. We were training people, but we didn't have an established way of working, and we needed one to make these people effective. So I'm going to talk about 2 key aspects of our SRE way of working: how we measure reliability and how we elevate reliability. Okay, so let's take a step back. How is reliability measured? So before SRE, in the dark ages, technical availability, or SLAs, were the leading indicator of reliability, which we know is problematic because service can be technically up, processing lots of errors, or technically up and slow. And so despite you not breaching your SLAs, customers getting a terrible experience. And this is a perpetual source of frustration between technology and business teams, because technology teams go to the business stakeholders at the end of the month. Hey, we're green, nice green scorecard, and the business throw their toys out the pram because the customers are unhappy. Big step forward with SRE. SLIs and SLOs encourage us to measure outcomes that customers care about. So the SLI menu: latency, throughput, coverage, freshness, much more relevant for measuring reliability through that customer lens. However, we think there's still a small watermelon there that we need to talk about. Because even with SLIs and SLOs, how do we know how the customer really feels? Or if the outcomes that a customer wants change? Or if the customer expects different service levels? Observability by nature is inward looking. It's looking at the inner state. And SLIs and SLOs traditionally are internal proxies for that customer sentiment. And if as I think we all agree, customers define our reliability. There's a great quote there from Dave Renson from the SRE Bible. Your users, not your monitoring, decide your reliability. If customers do define our reliability, we should expand our evaluation of reliability to include data that we get direct from the customer. So I'm talking about qualitative data. It's a really valuable source from which reliability can be inferred that allows us to reconcile what our internal markers, our internal metrics are telling us. So net promoter scores, customer satisfaction surveys, customer queries are a great source of how the customer is experiencing your product. Customer effort surveys, social media, customer complaints. And this allows us to arrive at a solution that blends together those internal technical markers, your SLIs and your SLOs, with the qualitative data that allows you to prove that you're measuring the right stuff internally. So qualitative metrics validate our internal technical understanding versus the customer's perspective. So when we onboard a new product to our observability platform that Sri's going to talk about later, we offer those product owners an experience indicator menu of the different data points that are available for us to measure reliability for their service. So the business tells us how they want us to measure reliability. We don't decide, which instantly builds a bond with those key stakeholders. So not all of those metrics will be applicable to every service, but we work with the business to decide which ones we need to measure. And we don't stop there, because those metrics on their own are just a service management view. If you think of most product ecosystems in big countries, the ecosystem is spanning multiple business lines. So this is an example of a payment product ecosystem from Standard Chartered, fast payments. You have the channel application where the payment's initiated. That's owned by our digital channel group. And then you've got payment routing and payment processing. That's owned by the cash business. And then you've got core banking where the credit or the debit happens. That's owned by our retail business before the payment finally goes to clearing. So if you're an SRE...
Just to add to that point, this value chain, especially when it comes to fast payments, is typically regulated by the regulators in each market. So in Singapore, those who are using instant payment, pay now, would know it's 9 seconds. In Malaysia, it's 5 seconds. In Hong Kong, it's 15 seconds for those transactions to get through. So we are regulated. So if you think about 20 years ago, we said the fastest thing was algo trading, low latency, high frequency. You still had 5.5 days of uptime. But with this, it's 24/7. So the challenge is completely different.
Yeah. And if you're an SRE and you know where the problem is, sometimes it can be challenging to get that sponsorship to do something about it. So we use that experience data, the blended qualitative and quantitative data. Our SREs then make a targeted set of recommendations that get mapped onto the end-to-end ecosystem to influence product owners. Okay, so challenges with this approach to measuring reliability. So we're heavily dependent on distributed functional tracing. Sri's going to talk more about that. Depending on your product, that can get super complex, lots of edge cases that you need to explore to make sure you're measuring accurately. And if you don't do that, you open yourself to accusations that it's just another watermelon. So you have to go down those rabbit holes to make sure you can talk confidently about how you're measuring. Aggregation. Data's spread all over the place, particularly qualitative data. It could be with the product team if it's surveys. It could be with the client service if it's queries. So there's a challenge aggregating the data. Everyone wants to improve client experience, but there's been a huge proliferation of operational tools, which means that data's fragmented. Granularity trade-offs, how low level do you go? Related to the DFT challenge, we go very low level because we found when we talk to people that have the money, that we want to spend money and get investment from, they want very specific details. So we go down in payment products, we go to the sub product to make sure we understand where the issue is. Suitability of qualitative data. By nature, qualitative data can be unstructured. If people are sending emails in, it could be all over the place. How do you infer sentiment and reliability from that data? You need machine learning or NLP. Some qualitative data is very easy. Net promoter scores, 0 to 10 ranking. Quantitative evaluation is very easy, but some of the qualitative data, a bit more challenging. And then how do you scale? So this approach adds the most value when it covers the largest percentage possible of the ecosystem. So are you going to roll this out with a product-driven view, where you do one product end-to-end at a time? Or are you going to look at a grouping of similar products and pick a metric that best represents the experience across those products, like payment latency, and roll that metric out horizontally? So something to consider. The key is to do this with the business. So whatever decisions you make, you have their support. Okay, so this is wrapping up measuring reliability lifecycle. So what we found really works is we have that blend of quantitative and qualitative indicators. The quantitative data is embedded in our technology and operations teams real time. We don't have real-time qualitative data yet, but that's something we're exploring. That data gets aggregated into a point-in-time analysis and then gets fed into the investment lifecycle with targeted recommendations, so we maximize our ROI. Okay, so that's measuring reliability. Elevating reliability. There's two key components to elevating reliability as we see it. How do we measure that non-functional capability? And then how do we industrialize solutions for a consistent implementation when we understand where the problem is? Because when you have a problem, you don't want everyone having to recreate the wheel. So a quick recap on the tenet framework. Tenets are the columns: reliability, scalability, operability, observability. And then the subtenets are the specific activities and capabilities underneath there. So how do we measure application capability? Each of those subtenets gets broken down into lots of elements, about 90 elements across our framework. So for example, in this example, always-on deployment architecture, we've broken it down into the different elements that we would expect an application to have to be able to deliver an always-on application architecture. So the key is to agree a methodology for how you're going to measure your application's non-functional capability, because then this will drive your day-to-day SRE activities. Particularly if you're transforming, you're going to have lots of people that don't know how to do SRE. And so this gives them the structured way of working where they can evaluate their applications and then understand what to do next. So this is very similar to the R9Y framework. That's an open source project that I think Google are involved in. The link's there, take a look at it. It's very, very helpful. Okay, well, if you do that, you can aggregate the data, and then you can visualize your capability end-to-end. So auto-deploy subtenet is graded for the application. All the other subtenets get graded for the application into an application view of that application's non-functional capability. And then you can even go one step further and aggregate the applications that support the ecosystem into a journey view, say for payments. So the key is when you do this is to remove subjectivity when you're evaluating and focus on the outcomes. So you don't want everyone doing this evaluation a different way and coming up with garbage data. So we're experimenting with a combination of technical markers and ITSM data. So if a team comes to us and they say, hey, we can do 0 downtime deployments, we'll get their CRs, look at their change windows, and look at their unplanned and planned downtime, their availability metrics within that change window to make sure that they are actually 0 downtime. If any of you have any ideas about how we can do this better or evaluate non-functional capability at scale, I'd love to hear them. So the extension of this very detailed breakdown of that tenet framework is we can also map reliability patterns to it to industrialize the solutions. There's a great quote there from Henry Ford. If everyone moves forward together, then success takes care of itself. What we don't want is every SRE trying to figure out these problems themselves. So our SREs contribute to the in-house reference framework. And we try to, this is key, this is a key takeaway, we try to reward innovation through reuse and collaboration, not rewarding creation. I think a lot in technology organizations look more favorably on creation rather than reuse. And if you're going to scale this, you really need people to be comfortable being rewarded for reuse. Okay, so this is just wrapping up our SRE way of working, and I'm going to hand you over to Sri for the fun stuff, which is the tools. So there's 3 inputs to our SRE way of working: the non-functional evaluations, the experience data, which is a blend of quantitative and qualitative data, and then thematic analysis from our production incidents. So we use failure mode effect ref analysis. Haven't spoken about that today. This feeds into an SRE book of work, and then when that work's prioritized, they refer to the reliability patterns for implementation guidance. Our people and systems are graded using the same tenet framework, so it's consistent. Okay. Thank you. That's people and process. Now the fun stuff.
Thank you, Ian. Okay, so we've covered people, process, but you can't do transformation without building capability. And typically tools are enablers for transformation. So I'm going to cover observability in a bit of detail. So traditionally, I'm sure all of you would have seen those beautiful screens with traffic lights. They have context to an application. They may not have context to the overall journey. You will see signals, and those signals, if I relate it back to the previous talk before the break, you may have the same engineer looking at those signals. Because he's an SME, he's able to infer. But then once you put a rota, the inference does not happen because it can be complex. And so when you look at one dashboard for one system and 5 dashboards across the journey, you may have different signals. So you understand there's a problem, but you can't infer the impact radius, and it may need an SME knowledge. So what that builds is a culture of creating heroes within this organization, and it's not sustainable. So traditional monitoring is obsolete when it comes to digital economy, while observability, it is much more aggregated at a higher level. Traditional monitoring has a space, but it's more like a decomposed data at a much more explained level. Okay. So the challenge we had was our engineers were eyes on glass. They were looking at 450K alerts and events per month. They were slow to infer and understand where the impact is. By then, we would have customers calling us saying there's a problem. So the customer knows the problem before we've seen the problem. And given that we are a financial institution, we are regulated, and so there is risk that we may breach some of the timelines and cutoffs. So we definitely needed to change this. Okay, this slide, a bit busy, but I'm sure most of you would have seen something similar. The starting position is let's bring all data into time series, right? So let's bring metrics, logs, traces, and events in time series. First step. Step 2, if you remember the first slide when Ian spoke about L1, L2, L3, and we talked about production intelligence center, we built data engineers. Now we asked data engineers to go back and look at all markers which have caused incidents in the past, because we have a big repository of failure points, and also predict markers which can, if all stars align, can cause a problem. So we then got to a big set of patterns. These patterns, we back tested it with machine learning, and then we made sure that we understood the markers in collection as a pattern are the right ones, which, if it happened again, would cause an issue. Now, when we did this part of the exercise, it allowed us to do 2 things, right? One, we understood the correlation of the markers across platforms and journeys. 2, it also gave us the vectors that we would use to give ranges and tolerance level for these markers, because we use them on streams of data through Spark clusters as data came in, so that we could predict those problems. Okay, so this is the 3 steps. I will refer to A, B, C in the upcoming slides, so that I will give some examples of what we did with this approach and where we are. Okay, first one was noise. Noise was a problem, So in 2021, we had 5.5 million alerts sent to our crew. Unsustainable, makes no sense. And with the digital economy where you have very little time to react, and if you see the previous session, again, there were some really good slides from the previous session. I think we spent 3 minutes in the toilet, 8 minutes to take a shower, 20 minutes to have a meal. If we have so many alerts and there are people on rotation, they have very little time to react because you're trying to find a needle in a haystack and there are a lot of false positives. So we actually used machine learning to look at this data and get into k-mean clustering to give some prediction of what our tolerance level for these samplers should be. We are halfway through the journey. We've reduced this noise from 450 to 200. By Q1 next year, we want to reduce it by 95% from start. Okay, and that's really, really working. We've applied this across our main platforms, which are creating maximum noise. But this is one use case of the observability platform that we've built. Okay, I want to go back to the previous slide and this slide. When I talked about traces here, typically you would have traces with APM, and you will also, you know what distributed tracing is, typically across clusters. And if you were to use OpenTelemetry in current form with some of the tools, you can actually trace this across clusters, et cetera, et cetera. But then, if you remember when I started off, I said we are an old bank. We have an architecture which is interweaving old and new. And when I say old, we're talking about mainframes, mid-range, COBOL. Okay, and these are old systems. They don't have standardized instrumentation, nor can you apply APM to them. So how do you really understand where a transaction is for a customer at any point in time? Okay, so while we had time series data, we didn't have distributed functional tracing for the transactions. And this was a problem we had to solve. So what did we do? Given we are a bank, obviously we rely on Swift standards a lot. So we applied UETR for all payments that we process. So now every transaction eventually as a banking institution results in some kind of a payment. So we basically tag it to a UETR. We forced a custom JSON structure which allowed us to have information about state changes of transaction as it went through the life cycle and the main milestones of the life cycle across systems. We ingested that real time, and we built really low latency code which allowed us to stitch and give a current view of the transaction as the transaction was going through. Okay, so it was a sidecar pattern that we used, and we found it extremely useful, especially given the complexity of our architecture. Okay, and here we were able to bring the time buckets. In the time buckets, we were able to bring the business context, and we were also able to correlate this with technology problems. So as a principle, you can have infinite technology problems, but the business outcomes of those technology problems are very finite. Okay? So once we got that solved, we now had time series data. We had correlated data. We knew events from the past which have caused incident. We knew we could associate problems to business outcomes, and we knew what to tell the business when there's a problem, or make the AI ops engine infer where the problem could be. In order to get there, we obviously tried multiple ML models, Prophet, LSTM, Isolation Forest, Elastic. But then for all the use cases, we couldn't choose one ML model. So we are using an ensemble of models with the Spark cluster. And with now where we are able to predict probable failures. And because we're able to predict probable failures, it just allows us to be ahead before the client tells us there's a problem. Okay, and in a digital economy, if you are using fast payments, by the time you notice a problem, in a lot of cases, the customers will see the problem before you do. So the only way to beat the customer is to actually either isolate that blast radius in such a way that the experience is very smooth, or you have to be able to predict to understand this problem faster. Okay, so scale of implementation very quickly. So far, we've done 8 critical journeys, and we are continuing to work on some of these journeys because these are all STP flows. We've cut this across 30 platforms. We currently trace around 18K microservices across 40 nodes. We ingest documents around 28K per second, at peak 82K per second. We process around 10 billion DFT messages. We stitch that and give real-time views in a week. And in a week, we also do 70B general documents that we process. Okay, that's our tech stack. Now our observability platform, as Ian mentioned, is powering decision making for our product owners to make customer experience better. Our investment has improved our mean time to detect, and our mean time to resume has also improved. This is in relation to the event that's happening in the next hall, which is how do you unlock the potential of the production data? How do you then digitize internally? Because now we have rich data set, we are exposing this data set along with data from TP system with an API mesh to users so that they don't come and ask us questions which are mundane, and we want engineers to focus on engineering problems and not answer questions. So we built a virtual assistant, and we also have a rapid triage built on Twilio, with escalation rules, which allows to give context to the problem and tell where the problem is. Takeaways?
Go for it. Yeah, go
Takeaways? Why don't you start with the people?
Okay, people. Key takeaways. So North Star, I've mentioned it a few times, that North Star guiding framework was incredibly valuable. Gave us a foundation from which we're able to transform. L&D, having that detailed skills catalogue with the skill levels and the proficiencies described took a lot of weight off the central team to organise people's training. People were empowered to get on with the training themselves at their own pace, using that information that we provided to them. If you haven't done the Google, I think it's called is it managing an SRE culture or building an SRE culture? There's a Google online course along those lines. It talks really well about how to manage the psychology of the change. Definitely recommend you check that out. Obviously, there's a lot of resistance when you start to go through these transformations. Probably the most important, neuroplasticity. Neurons that fire together, wire together. If you don't give your people the time to apply these skills, the training is going to be a waste of time. You've got to carve out time for them to apply their new SRE skills, for them to build up that autopilot reflex action. Process. There's no point in training SREs if you don't give them the opportunity to be SREs. So in an organization, if it's a new role, that's going to require some changes to the operating model to give them the scope of responsibilities where they can be effective. So you make sure you do that. There's no point in training people if their role is not recognized. Definitely encourage you to extend your evaluation of reliability to qualitative data. It's been an eye-opener for us, and it helps you talk the same language with your business stakeholders. And then start small. I mean, you can try Big Bang, but we started small and adjusted as we went, because inevitably you won't know all the answers. You'll have to learn, iterate. So start with small pilots, figure out what works, demonstrate the value in SREs in your company, and then scale it. Tools?
Tools, yeah. So don't shy away from sidecar patterns. When you have legacy, you may not have the luxury of investment budget to re-platform. So you probably will have to rely on sidecar. Distributed functional tracing, or you may say understanding the customer journey as it happens, is super important. Observability, you can unlock so much of potential with that data. We're just scratching the surface at this point of time. Obviously, with the generative AI on top of that data, it will do wonders. Last but not the least, have a centralized core engineering team which is completely focused only on this, because it takes time to build that platform. And not necessarily that everything in the market will fit. It could be a mix of open source and licensed software. Again, it'll be up to the organization to choose what works for them best. Yeah.
Okay.
That's a wrap up.
You have 2 minutes back.